Good day, class. Welcome to the first edition of Scholars University Secondary School online chemistry class. I am Solomon and I will be taking the online chemistry class for this period. Now, today we are going to talk about halogens and their compound. Though today is just an introductory class to the lecture, in other classes we are going to discuss more about the halogens and their compound. So, today we are going to discuss about the members of the group. We'll talk about their electronic configuration. We talk about their occurrence in nature and also their properties. Halogen is a Greek word for salt formers, and it is the name given to elements that occupy the group 7 of the periodic table. And this is the periodic table, and here is the group 7 of the periodic table. The halogen family consists of the following elements: fluorine, which is represented as F with atomic number of 9, chlorine represented as Cl with atomic number of 17, bromine represented as Br with atomic number of 35, iodine represented as I with atomic number of 53, and astatine represented as At with atomic number of 85. And you can see them also at this column of the periodic table. This is the fluorine, this is chlorine, this is bromine, this is iodine, and this is astatine. And you can see that the atomic number of fluorine is 9, that of chlorine is 17, bromine is 35, iodine is 53, astatine is 85. Now, this last element is a newly discovered element, so we're not going to talk about it in our discussion about the halogen because research is still going on about the elements. Now to the electronic configuration. Now we know that elements with the same number of valence electrons belong to the same group, which implies that the members of the halogen family, the chlorine, the fluorine, the bromine, the iodine, and the astatine, have same number of electrons in their atomos shell. And for them to be grouped under the group 7 of the periodic table, that means they must have 7 electrons in their atomos shell. Now let's check the electronic configuration of fluorine and chlorine. Now, this is the new way of writing electronic configuration, and here is the old way of writing electronic configuration. Now this is the atomic structure for fluorine, and here is the atomic structure for chlorine. Now, if you check the electronic configuration of fluorine, you can see that the atomos shell, the 2s and the 2p, have 2 electrons and 5 electrons respectively. And when we sum both of them up, 2 plus 5, it gives us 7, which is also written here. Now let's count the number of electrons in the atomos shell of fluorine. We have 1, 2, 3, 4, 5, 6, 7. Now let's check the one for chlorine also. The atomos shell, the 3s and the 3p, have 2 and 5 electrons respectively. That's 2 plus 5, which equals to 7. Same as the fluorine. Now when you count this one also, the number of electrons in its atomos shell: 1, 2, 3, 4, 5, 6, 7. Now you can see that both fluorine and chlorine have 7 electrons in their atomos shell, which make them to be classified under the same group. So also the other members of the halogen family have 7 valence electrons in their atomos shell. Now to their occurrence in nature. Fluorine and chlorine are very reactive, so they are not found freely in nature, but in combined form with other elements. For example, chlorine exists with sodium in sodium chloride. The normal table salt we have atom, while fluorine with calcium in calcium fluoride, which is also known as the fluoride. Now the other members of the group, except astatine, can exist freely in nature and also in their combined form with other elements. Now we're still going to talk about the members of the halogen family individually. We're going to take each of them individually, but we're going to be focusing mainly on chlorine. The element also can be prepared in the laboratory when needed and also industrially. We won't be able to talk about the laboratory preparation and industrial preparation in this class. So this is just an introductory class. So when we are taking the members of the group, we'll talk about their laboratory preparation and also their industrial preparation. Now please take note that astatine is a radioactive substance. Therefore, it's not found freely in nature because radioactive substances undergo radioactive decay, which make them unstable and therefore change to another element when they undergo that decay. Now to the properties of the halogen family. Now when we talk about the properties of elements, we talk about the characteristics of elements. Now the properties of elements can be divided into two. We have the physical properties and also have the chemical properties. Now, when we talk about the physical properties, we talk about the physical state, the color, the solubility in water, the boiling point and the melting point of that element. And please let's take note that the physical properties of elements is determined by the atomic number, which is also same thing as the proton number. Please let's take note of that. While the chemical property is determined by the electron number, which is the same as the number of electron an element possesses in its atomic structure. Now, so the physical state and color of the halogens. Fluorine exists as a pale yellow gas, while chlorine exists as a gas but with greenish yellow color. Bromine is the only member of the group that exists as a liquid but gives reddish brown films in reaction. Iodine and astatine exist as black solid, but iodine gives purple films in some reaction. Please let's take note that all these are conditions observed under standard condition. That means at standard temperature and at standard pressure. Anything outside the standard condition will not give you any of these results. It can show a little deviation from any of these results. Please let's take note of that. Now to the solubility in water and boiling point and melting point. Now all halogens except from fluorine dissolve slightly in water. Fluorine reacts readily with water to produce oxygen. Now the boiling point and the melting point of halogen will be discussed in later classes. As I said, we are going to take each member of the group and we are going to discuss them in later classes, but we are focusing mainly on chlorine. Now to the chemical properties of halogen. Now from the electronic configuration, we know that they have 7 valence electrons in their atomous shell. That means they just need only one electron to attain the octet structure of the noble gases. We all know that elements and atoms they undergo chemical combination just to attain the octet structure of noble gases. Now halogen can attain this octet structure of noble gases by undergoing either electrovalent combination, which is also the same thing as ionic combination, or covalent combination. Now electrovalent combination is always with metallic elements like sodium, potassium, calcium and all metallic elements, while covalent combination is always with non-metals and even with themselves. Halogen undergo covalent combination with themselves. Now we'll discuss that in later classes. Now please take note that the negative ion of halogen formed when they exist in combined state with other elements is called halide. For example, that means the fluorine ion, the chlorine ion, the bromine ion, the iodine ion are generally called halide. Now the fluorine ion is called the fluoride, while the chlorine ion is called the chloride, bromine ion is called the bromide, iodine ion is called the iodide ion. Please let's take note of that. Now the main chemical properties of the elements of each member of the group will be discussed in later classes. Please let's take note of that also. So we've come to the end of today's class, which is the introductory class. Here are some assignments for you guys. Give the electronic configuration of bromine and iodine. Describe the physical properties of fluorine. Fluorine reacts with dash to produce oxygen. Please, I want you guys to go over the slides again and digest the content, and also check your textbook for further research and further reading and update your knowledge on them. And when we are discussing the later classes, I want you guys to update your knowledge about some topics, which is writing and balancing of redox equation. Please let's take note. This writing and balancing of redox equation will help us as we treat each member of the family, and also some knowledge about electrolysis, the factors that affect the discharge of ions in electrolysis. Please let's update our knowledge. The electrochemical series, I want to also update our knowledge on those areas of electrolysis. Thank you for watching this edition of Scholars Universal Secondary School Online Chemistry class. Once again, I am Solomon. Hope to meet you again in the next edition of the class. Thank you.